In the darkness between stars, something ancient drifts. For hundreds of millions of years, it has wandered through the Milky Way, a solitary traveler, untethered to any sun, crossing the void at speeds that defy human comprehension. Cosmic rays have peppered its surface, painting it the color of rust. It tumbles end over end through absolute cold, through silence so profound that time itself seems to pause. And then, in the autumn of 2017, it entered our solar system. By the time we noticed, it had already made its closest approach to the sun. Racing past at 196,000 miles per hour, it was already leaving. A visitor who never intended to stay. For just 11 days, humanity had a window to observe something that had never been observed before. An object from another star system, passing through our cosmic neighborhood like a message in a bottle thrown across an ocean of light years. We named it Oumuamua. In Hawaiian, it means a messenger from afar arriving first. But the messenger carried riddles. Its shape defied explanation. Its motion violated our expectations. And as scientists around the world scrambled to understand what we were seeing, a question emerged that would spark scientific controversy, inspire wonder, and remind us of how little we truly understand about the universe beyond our doorstep. What was Oumuamua, and where had it come from? To understand the significance of Oumuamua, we must first understand the cosmic architecture it emerged from. Our solar system exists within the Orion arm of the Milky Way galaxy, a spiral structure containing perhaps 400 billion stars. Between these stars lies the interstellar medium, vast stretches of near vacuum punctuated by clouds of gas and dust, bathed in radiation and swept by stellar winds. The distance between stars is staggering. Our nearest stellar neighbor, Proxima Centauri, lies 4.24 light-years away. A gulf so immense that even traveling at the speed of light, it would take over 4 years to cross. For decades, astronomers theorized that objects must occasionally be ejected from their home solar systems during planetary formation. When young planets jostle for position around newborn stars, gravitational interactions can fling smaller bodies into the darkness. These interstellar wanderers would drift through the galaxy like cosmic refugees, homeless and ancient, carrying with them the chemical fingerprints of alien worlds. The mathematics suggested such visitors should pass through our inner solar system about once per year. But they would be faint, fast, and nearly impossible to detect. Needles moving through a haystack the size of the solar system. That changed on October 19, 2017, when astronomer Rob Warwick, working with the Pan-STARRS 1 telescope on Haleakala in Hawaii, noticed something peculiar in his data. The telescope, funded by NASA's Near-Earth Object Observations program, had been designed to track asteroids and comets that might pose a threat to Earth. But this object was different. Its orbit was hyperbolic. A hyperbolic trajectory means the object was moving so fast that the sun's gravity could only bend its path slightly, not capture it. It would pass through our solar system exactly once, never to return. When astronomers traced the object's trajectory backward, they realized it had come from the direction of Vega in the constellation Lyra, a star 25 light-years away. On September 9, 2017, it had passed within 23 million miles of the Sun, closer than Mercury's orbit, heated briefly by our star's warmth. By the time we spotted it, Oumuamua was already 21 million miles from Earth, receding at 85,700 miles per hour relative to the Sun. The discovery was historic, humanity's first confirmed interstellar visitor. But what exactly had we discovered? Immediately, observatories around the world pivoted toward the rapidly receding object. The European Southern Observatory's Very Large Telescope in Chile, the Hubble Space Telescope, the Spitzer Space Telescope, ground-based facilities across multiple continents. Time was precious. Every hour, Oumuamua traveled further from the sun, growing fainter, slipping beyond the reach of even our most powerful instruments. What they observed was unprecedented. First, the object's brightness fluctuated wildly, by a factor of 10, every 7.3 to 8 hours. This variation was far more extreme than any known asteroid or comet in our solar system. The light curve suggested the object was not spherical, not even close. Scientists calculated that Oumuamua must be extraordinarily elongated, roughly 10 times longer than it was wide. Imagine a tumbling football, but stretched to impossible proportions. Or perhaps, as later analysis suggested, something shaped more like a pancake, flat and disc-like, rotating as it tumbled through space. The dimensions? Estimates placed Oumuamua at approximately 400 feet long and 115 feet wide. Some models suggested a pancake-shaped disc with proportions of 115 by 111 by 19 meters, like a cosmic cookie, one scientist would later observe. Its exact shape remained uncertain, shrouded in the limitations of observation. We could only see it as a point of light, even through our most powerful telescopes. Second, spectroscopic analysis revealed it was reddish in color, similar to objects in the outer reaches of our own solar system. This reddening suggested prolonged exposure to cosmic radiation, evidence of hundreds of millions of years spent wandering through interstellar space. The object appeared dense, possibly composed of rock and metals, with a surface irradiated to a rusty hue by the unfiltered violence of galactic radiation. Third, and most perplexing, Oumuamua had no coma, no tail, no visible signs of outgassing. When comets approach the sun, solar heat causes surface ices to sublimate, creating glowing halos and spectacular tails of gas and dust. But Oumuamua remained stubbornly inert, showing none of these signatures. It looked like an asteroid. It behaved, in most ways, like a dead rock. Which made what happened next utterly baffling. On June 27, 2018, a team led by astronomer Marco Micheli published findings in the journal Nature that would ignite scientific controversy. They had detected non-gravitational acceleration. When astronomers tracked Oumuamua's position with extreme precision, comparing hundreds of observations from ground-based and space-based telescopes, they found something impossible to ignore. The object was deviating from a purely gravitational trajectory. Something was pushing it. The deviation was tiny, about 5 micrometers per second squared, roughly 30 times weaker than gravity at Earth's surface. But it was real, detected at 30 standard deviations of statistical significance. It was accelerating away from the sun. For comets, this behavior is normal. Outgassing creates a rocket-like thrust, but Oumuamua had shown no tail, no visible jets of escaping gas. How could it accelerate like a comet while looking like an asteroid? Scientists proposed a cascade of exotic explanations. Perhaps it was a hydrogen iceberg, formed in the frigid core of a molecular cloud. Perhaps it was a fragment of a nitrogen ice world, like a chip broken from a distant Pluto-like exoplanet, sublimating so smoothly that it left no detectable debris. Perhaps solar radiation pressure was pushing against an impossibly thin, reflective surface. Perhaps it was outgassing materials we simply couldn't detect from Earth. And then came the most provocative suggestion of all. Harvard astronomer Avi Loeb, in a paper co-authored with Shmuel Bialy, proposed that Oumuamua might be a light sail, a thin, artificial structure designed to harness the pressure of starlight for propulsion. If the object were less than a millimeter thick with a large surface area, radiation pressure from the sun could explain its acceleration. Loeb argued that Oumuamua's extreme elongation, high reflectivity, and anomalous acceleration made it consistent with manufactured technology, perhaps a derelict probe from an ancient alien civilization, drifting through space like cosmic flotsam. The hypothesis ignited fierce debate.
Some scientists praised Loeb for thinking boldly. Others accused him of sensationalism, of invoking extraordinary claims without extraordinary evidence. The controversy spilled beyond academic journals into popular media, where Oumuamua became synonymous with the question that has haunted humanity since we first looked up at the stars. Are we alone? But in 2023, a simpler explanation emerged. Jennifer Bergner, an astrochemist at the University of California, Berkeley, and Darrell Seligman, an astronomer at Cornell, proposed a solution rooted not in alien engineering, but in physics known since the 1970s. When ice is bombarded by cosmic rays, high-energy particles that permeate interstellar space, molecular hydrogen forms and becomes trapped within the ice structure. As Oumuamua approached the sun and warmed, this trapped hydrogen was released. Because Oumuamua was so small, an order of magnitude smaller than typical comets, even a modest release of hydrogen gas could produce enough thrust to explain the observed acceleration. And because hydrogen is invisible to most Earth-based telescopes, especially through our atmosphere, the outgassing would have been undetectable. The object was behaving like a comet all along. We just couldn't see the evidence. The hydrogen outgassing hypothesis offered an elegant resolution. Oumuamua was likely a water-rich planetesimal, processed by cosmic radiation over eons of interstellar travel. It was natural, ordinary, a comet fundamentally, though unlike any we had seen before. But Loeb remained unconvinced. The debate, like Oumuamua itself, continues its trajectory outward.
By January 2018, Oumuamua had traveled beyond the orbit of Saturn, more than 2 billion miles from the Sun, fading beyond the reach of even the Hubble Space Telescope. It is gone now, racing toward the constellation Pegasus, a speck of matter returning to the void from which it came. In tens of thousands of years, it will pass other stars, indifferent travelers in the galaxy's slow dance. We will never see it again, yet its legacy endures. Oumuamua forced us to confront the limitations of our understanding. We had theorized about interstellar objects for decades, but theory and observation are different languages. The object's discovery validated predictions, yes, but it also revealed how unprepared we were for the reality. We assumed the first visitor would resemble the comets we know. We assumed we would have time to study it. We assumed we could definitively categorize it. We were wrong on all counts. The mystery of Oumuamua also catalyzed new efforts. The Galileo project, founded by Avi Loeb in 2021, now searches for interstellar objects and unidentified aerial phenomena, preparing for the possibility that future visitors might provide clearer answers. The Vera C. Rubin Observatory, which began operations in 2025, is expected to detect 1 to 3 Oumuamua-like objects every year, offering opportunities to study interstellar visitors with better preparation. And Oumuamua is no longer alone in its category. In 2019, astronomers discovered comet 2I/Borisov, the second known interstellar object, which behaved far more like a traditional comet. In 2025, a third interstellar visitor, 3I/Atlas, was identified. With each discovery, the census grows. We are beginning to map the population of wanderers that drift through our solar system unseen. More intriguingly, Oumuamua led to the identification of dark comets, small objects within our own solar system that show non-gravitational acceleration without visible cometary activity. By 2024, astronomers had identified 14 such objects. What we initially thought was alien may simply be misunderstood. The universe, it seems, harbors varieties of objects our models have not yet imagined. There is a stillness now in the wake of Oumuamua's passage. It traveled for hundreds of millions of years, perhaps 500 million, through the cold between stars before entering our solar system around the year 1837. For 180 years, it approached unnoticed. And when we finally glimpsed it, we had 11 days to study a messenger older than our species, shaped by stellar systems we can only imagine. In those 11 days, Oumuamua reminded us of a truth easily forgotten in the rhythm of daily life. We are part of something vast. The galaxy is not empty. Objects drift between its stars, carrying histories written in ice and stone and radiation. Some may be natural. Some, perhaps, could be the work of minds like ours, or minds we cannot yet conceive. The debate over Oumuamua's nature, comet or artifact, accident or intention, reflects a deeper question about how we approach the unknown. Do we leap toward extraordinary conclusions, or do we exhaust the ordinary first? Science demands both caution and imagination, skepticism and wonder. The tension between these impulses is not a flaw, it is the engine of discovery. Oumuamua is gone, but it has seeded questions that will outlive us. When the next visitor arrives, and the next after that, we will be watching. We will be ready. And in the silent moments between observations, as telescopes scan the dark, we will wonder, as we always have, what other messengers are crossing the void, unseen, carrying their secrets through the endless, patient night. Perhaps, somewhere in the galaxy, another civilization once watched Oumuamua pass their world. Perhaps they too wondered. Perhaps they are still wondering, as we are, gazing into the same darkness, asking the same question. Are we alone? The universe, for now, holds its silence. But Oumuamua reminds us, the answer, one day, may arrive.